For today's lesson, we are going to find the axis of symmetry and the vertex of a parabola. So for your lesson preview, I hope you remember how to find the zeros of your graph. Now the vertex is the point that's the lowest or the highest on your quadratic function. In this problem, the vertex is 1, -4. Now, the range is the y value, the y values of your graph. The smallest y value that you see is -4. So all of your y values are greater than or equal to -4. Now the axis of symmetry is the line that if we were to fold the graph, you get the same picture. Do you notice that's a vertical line? And that vertical line is x equals 1. So if we can identify the axis of symmetry, we can get a pretty good picture for each one of these functions. So when we write the equation for the axis of symmetry, we write x equals 1. And did you notice that the vertex, which has an x value of 1, -4, is the same value for the x that you came up for your axis of symmetry? And did you notice that your zeros are evenly placed on either side of the axis of symmetry? So with these ideas, we're going to be able to graph the quadratic equations, and quadratic functions are called parabolas. So we're going to draw and state the axis of symmetries. First, notice the axis of symmetry goes straight through the vertex. The vertex in this problem is -1, 0. And if we state the axis of symmetry, that's the line x equals -1. Again, notice the connection. X is -1 for the axis of symmetry and for your vertex. Now, how are we going to find that axis of symmetry without graphing it every time? We're going to write our problem in standard form. Then we're going to look at the coefficients. In front of the x squared is a 1. In front of the 2x, in front of the x is a 2. And then you have that constant 1 just hanging around. So in standard form, which is ax squared plus bx plus c, we can match up that the a is 1, the b is 2, and the c is 1. Now, your vertex is going to be written as an x and a y after we find the axis of symmetry. And that's actually the average value of your two zeros. To find that, we're going to take the -b and divide it by 2a. So our axis of symmetry is x equals -b divided by 2a. So in this case, the vertex is -1. That's kind of what we were expecting. Now, if we know that the x is the axis of symmetry and we want to find the y to write our vertex, fortunately, at the very top, you were told that y equals your x squared plus 2 times x. Make certain you use parentheses again when you do your substitution. And what you end up with is the y value is 0. So now we can find the vertex and the axis of symmetry of each problem. So let's give this one a try. In order to find the axis of symmetry, we're going to let x equal the opposite of b over 2a. Let's find our values. A is -3, b is 10, and c is 9. So when we substitute, we're going to get -10 over 2 times -3. We'll reduce our fraction and we get 5 over 3. So the vertex, we have the x is 5 over 3, and now we have to find the y value. Y is -3 times our 5/3, which is going to be squared, plus 10 times our 5/3, and then we will have plus 9. So this gives us -5 over 3 plus 25 over 3 plus 9. So positive 20 over 3 plus 27 over 3, which comes out to be a nice little 57 over 3. And does that divide nicely? Of course it does. And then we have 19 as the vertex. So 5/3, 19. So for question 4, let's find that axis of symmetry. We want the opposite of b over 2a, so it's going to be an x value. And the b is a 1 over 2 times 2, so it's the opposite of 1, so that's negative 1/4. Okay, determine the vertex. So we know the x value is negative 1/4, and we want to find the y value. Y is 2 times 1/4 squared is 1/16 plus 1/4 minus 1/4 plus 3. So that's going to give us a 1 over 8 minus 2 over 8 plus 24 over 8, which equals 23 over 8. So our vertex is at 23 over 8. Okay, so to find the zeros of a quadratic function, there's an x value that's going to make your function equal to 0, but there's also an x-intercept, and that's where your y equals 0. Your quadratic function could have 1, 2, or no zeros at all, and averaging those zeros can help you find the axis of symmetry. The axis of symmetry is a vertical line, and that vertical line passes through the vertex, and it's going to be used to help us find the vertex of your parabola. So for example 5, we're going to find the vertex, x-intercepts, range, and the minimum and maximums of our parabolic function. So let's take a look. Let's first know that a is 1, b is negative 1, and c is negative 2. To find the vertex, we're going to start with x equals the opposite of b over 2a. And now we need the y value. So when we have x is 1/2, y equals 1/4 minus 1/2 plus 2, which is going to give us a 1 3/4. So we now know that the vertex is 1/2, 1 3/4. All right, now I want you to think about that for a minute. That tells you the minimum value of this function is going to occur. X is 1/2, 1 3/4. So the minimum is going to be at y equals 1 3/4, because this parabolic curve opens upwards. Now, the range of your problem. The range is y is greater than or equal to 1 3/4. The x-intercepts. So to find your x-intercepts, we're going to set our function equal to 0 and factor. So x minus 2 times x plus 1 equals 0, and your x-intercepts are going to be 2, 0 and negative 1, 0. All right, there's a lot going on there. For example 6, similar problem. The vertex is where we're going to start. Please note that a is negative 1, b is negative 1, and c is positive 6. So the axis of symmetry, x is the opposite of b over 2 times a, and that'll be negative 1/2 this time. Next we'll find what y is equal to, and that gives us negative 1/4 plus 1/2 plus 6, and when we do that, we will have 6 1/4 as the y value of our vertex. So negative 1, 6 1/4. Do you notice that the a value was negative? So that means that this parabola is upside down. How is that important? When we think about the range are your y values, and the largest y value is going to be 6 1/4. So y is less than or equal to 6 1/4, and it is a maximum. And the maximum is going to be 6 1/4. For example 7, so we have this nice little equation here. Pebbles dropped from a 256-foot cliff. We have an equation that can be used to find the height h of the pebble. Find the vertex. Okay, our problem is not in standard form. So if I solve for h, I get negative h equals your 16t squared minus 256. But then h is negative 16t squared plus 256. To find the vertex, it's the opposite of the b. Wait, b is 0. So t is going to equal 0 to find the vertex. And when I substitute 0 in, h equals 256. So my vertex occurs at 0 to 56. Determine the height of the pebble after falling for 2 seconds. So h is going to be equal to negative 16 times 2 squared plus 256. Simplify that and you will know the height in terms of feet after dropping the pebble. When will the pebble reach the ground? Remember, on the ground, the height is 0. So take your equation. 0 equals negative 16t squared plus 256. I don't like that I have a negative in my problem, so I'm actually going to, I also see a GCF of negative 16. Let's pull that out. So we have t squared minus 16. So when I factor, I get negative 16, t minus 4, t plus 4. So my two answers are t equals 4 and t equals negative 4. But can time be negative? No, just t equals 4. For example 8, we're looking for the zeros. We're told that the zeros of the parabola are 1 and negative 2. So we can sketch this parabola. What else do we know? That the maximum of the parabola is at y equals 3/4, and the axis of symmetry is at negative 1/2. So if we have this information, that's your vertex. The vertex is negative 1/2 and 3/4. So let's plot negative 1/2 up 3/4 and draw our parabolic function. There we go. What are the factors of this quadratic? Since x equals 1, x minus 1 must be 0. Since x equals negative 2, x plus 2 must equal 0. So my factors are x minus 1 and x plus 2. These are our reminders of some of the formulas that we've been working with today.